everyone. Welcome to the IEEE Communication Society podcast series. This is episode number 9. We are here to discuss about the industry aspects and experimentation work around the latest 6G technologies that are going on. And we are fortunate enough to have several of the experts who are taking part into the IEEE PMRC 2024 and 160 Summit 2024 that is happening in Valencia now, as you can see with me. So let me introduce my colleagues. So first I have Meik Kottkamp. He's the technology manager from Rohde Schwarz in Munich, in Germany. Then I have Andrea Conti with me. He's a professor at the University of Ferrara in Italy. And then I have Paul Harris with me. He's a principal wireless architect in VIAVI Solutions in the UK. So here we are with our expert speakers. So they are well-known names. I don't really need to introduce enough, but we will start talking about some of the sort of technical aspects on the 6G. So as you see here, that we have IMT 2030 sort of framework, the 6G framework, recently adopted by the ITUR. So that discusses several of the enhanced capabilities in addition to what we had in our triangular framework of 5G, right, with the enhanced mobile broadband, ultra-reliable low latency, massive machine type communication, so on. So now we have some new additions there. So additions are integrating the AI and communications together, integration of sensing and communications. Then also we have the ubiquitous connectivity, right? So as you guys are working on several of these technologies, right, especially the integrated sensing and communication, we can pick. So maybe Mike, you have the expertise on that. Maybe I can start with you. So what do you think about, let's say, the activities, the industry activities that have been going on? And any pre-standards or standards activities, if you'd like to touch on the technology itself, on integration of sensing and communication, please.
Right. So yes, of course, I think this subject of integrating these two capabilities in one technology is really the new aspect that we have in 6G, and an important new aspect. It has a strong advantage towards creating a virtual world, digital twins of what we have in our environment. So this is a key capability, I guess. And we see quite a lot of activities in this respect. We have even standards activities in ADSI going on, touching that subject. We have initial work already now starting in 3GP for channel measurements and channel modeling. Right. And of course, we see a lot of, I think, project demonstrations where people try this out and try to assess the performance of this. Right.
So that's very, very good. So you also have a demo coming up in the 160 Summit on this technology itself. So would you like to share with our audience something about that?
Yeah, sure. Very, very nice. So, I mean, the principal subject in our demonstration is that, of course, coming from communications, we are used to know how to assess performance in terms of video quality, audio quality, or maybe physical layer measurement, right? Now, when it comes to sensing, this is for communication people a new thing. It's not the same as in the past, because we are used to emulate the one or the other side in communication testing. We say, okay, this is a transmitter, we put something into that receiver maybe, or we measure the transmission from that. But for sensing then, we have to have a different task, because now we have to provide kind of reference objects.
Definitely.
And that's the key of our demonstration. So, I mean, of course, it's easier if you have an instrument that is capable of doing some reference object emulation that is reproducible and maybe can be set in different ranges. Whereas with real objects, this is a little bit hard to repeat, do the very same thing again. So the demonstration shows how you can, any device that is sending out something, we get it as a signal, we reflect it such to emulate these numbers of objects in that demonstration or in that instrument. And then the device and the test can evaluate how good it is, how good is the resolution of two different objects that come closer to each other, or how good is the speed, accuracy I can detect, and stuff like that. So this would be the key to assess a certain minimum performance. Of course, you need to make sure about in your hardware, in your software algorithms, before you then maybe on top of that even discuss classification of objects and stuff like that on top of it.
Exactly, very interesting points. And it also brings me, to one topic where we talk about the spectrum side of it, right? So we have these multifunctionalities, we use sensing and communication, but how to really co-channel these technologies together, or if you're using a dual function signal, how to use, what kind of spectrum solutions you need to use for these. So Andrea, I know that, you work on different aspects of, spectrum, like millimeter wave and so on.
Yeah.
So would you like to touch something on that related to ISAC or millimeter wave bands?
Yeah,
anything like that.
Thank you. Nice. So, so my group, we are working on location awareness, or more in general situation awareness. So, localization and sensing. So either active or passive localization or using signal of opportunity is something that we are very interested in. Of course, coming from academia, we base our research activity on 3 pillars. So first, theoretical foundation, which is the very best with a certain type of signals or a certain type of bandwidth you can obtain.
Yeah.
And then we develop algorithm that aim to be technology agnostic, and of course then the reality and the performance on the field will depend on the strongly the technology, and then we build some demonstration on it. So here, for example, we are demonstrating 2 functionalities that you mentioning. So one demonstrator is about wireless sensing. So it is a real-time demonstration where we have an off-the-shelf millimeter wave radar.
Right.
This is a typical radar for automotive. It is an FMCW radar operating at 77 gigahertz with 1 gigahertz bandwidth, and it is a MIMO 2x16 antennas. And on top of it, we develop a signal processing chain to be able to first detect object in a certain area, then track this multiple target with an accuracy that we aim to be in the order of few centimeters, and then also classify, as you were mentioning, classify the type of object that we have. Either it is a person or a robot, and we foresee this to be specifically important, for example, in application for the factory of the futures, where you have AGV and person working together, co-workers. The other aspect that we are demonstrating is about location awareness. So how in 3GPP settings and according to 3GPP specification, 5G, beyond 5G, and in the near future 6G can assist localization with accuracy that get closer to the service level requirement that the technical specification have defined. And here is interesting to see how to exploit different type of measurements, either in the frequency range 1, so below the 6-7 gigahertz, or at the millimeter wave, as you were mentioning, as well as in the near future in FR3 and the new frequency band. And we are showing how some new methodology, which is relying on probabilistic approaches rather than single value estimates of angle of arrival or departure and time difference of arrival, can really improve this performance. So we have these 2 demonstration, and my perspective is that location awareness or situation awareness is important, and not only because it enables new services that we might discuss later, but also because by having those information, you can have a smarter management of your network. For example, a physical layer for the beam tracking, or as soon as we will be really into the terahertz beam focusing also. So that's what we are.
I mean, you made a great point.
On.
Yeah, you made a great point. So basically, when you talk about adding sensing capabilities to your communication infrastructure, you need really high accuracy for localization, positioning, and many other sort of related aspects. And for these applications like robotics or using AGVs, and it has been also included in the 3GPP releases about work about these. There are many industry use cases, right? In smart healthcare, in let's say in some sort of augmented human sense, or any sort of detection that you want to do. So it's very important that you touch upon this point. So Paul, as well, I mean, you work on several of these technologies on related to the sort of 6G enhanced capabilities that we are talking about. So would you like to add something about your demo and the test bed that you have been working on, or any activities that you have been involved into your sort of around the 6G framework? So please, if you'd like to share that.
Yeah, thank you. So I guess in a general sense, to describe our 6G kind of project on the wireless side, we have a division within our wireless business unit, which we refer to as VIAVI Marconi Labs, and they're focused on exploring some of these candidate technologies, what's on the horizon in line with the IMT 2030 kind of vision, and also considering where things are currently at in the standards, what's emerging through 5G Advanced that maybe will reach maturity more in the 6G kind of phases.
Right.
So we've focused on developing an in-house platform to help us evaluate some of these, and particularly as a test and measurement company, we're trying to look at what impacts they will have potentially on how we need to approach testing. So At the 16G summit, we are demonstrating our AI, our neural network receiver. With that, we've taken an approach of looking at what parts of the receiver could gradually get replaced with different AI components, up to the point where you could have a fully AI receiver. And in that process, you could consider keeping everything as it currently is in 5G NR, but perhaps enhancing the channel estimation process. Maybe removing the pilots, allowing the system to learn on transmission what the best constellation would be. Removing the cyclic prefix, and considering kind of more and more extreme kind of cases.
Yeah.
And then streamlining the receiver chain to have a full neural network of different types of neural network receivers. So what we're showing really is how that could be a progressive thing, rather than maybe a completely disruptive thing we're tearing out and sticking in a fully native receiver from day one, but more how that could evolve, and considering what types of scenarios as well that really would be helpful for, and where it would actually be useful, and where the limitations might be, right, with generalization, and how we need to consider the scenarios.
You also end up with a lot of complexity issues here, and some security issues too, perhaps.
Yes. Yeah, you've got to consider that, right? Like, what additional complexity does it bring, and what are we aiming for? And in a general sense, I think that's with the ITR framework as well. What we need to think about, there's a lot of candidate technologies listed in these white papers.
Yeah.
All of them could have some merits in some ways in introducing new opportunities, new business cases. But I think we also need to reflect on what we can learn from the kind of 4G to 5G journey, and perhaps how we should focus on considering what technologies are going to enhance the real needs of kind of consumers or new business opportunities, and focus from that point first, and then step back and look at the technologies and how they could enable those, rather than a technology for technology's sake.
Sure, yeah.
Approach,
and
I guess.
This really leads me to sort of discussion on, let's say, what kind of use cases we can have of we discussed several diverse sort of approaches now with AI, sensing, comms, localization, and so on. So what kind of use cases and new opportunities we can think, let's say, when we talk about 6G? So, okay, sensing communication is not something quite new. I mean, it has been going on for, let's say, over a decade, but it has made the way out in 6G, and it is a very important technology that is being considered. So what kind of new use cases, opportunities, or any synergies that we can think with other technologies, let's say, when we combine sensing and communication, maybe we implement on non-terrestrial networks, on flying platforms or robotic scenarios, as we discussed. So what do you guys think? Anyone who would like to mention?
Yeah, I mean, from the sensing perspective, I guess, of course, there have been different scenarios. There are listed, you have thousands of white papers listing many, maybe.
Yeah.
So my perspective, I guess, we have in the industrial environment a good chance to really use it and then start using it. Also I guess for any sort of drone flying detection things or coordinating things there in that environment, I think there is high interest for people going ahead with that. And this is, of course, new. And as I mentioned earlier, this creation of a virtual world and transporting our knowledge now from the physical sensing into a digital world, and then play around with things there before we really adopt our real world, right? So I think this is really the main direction people are working on, and that would allow a lot of new things to take place in the future, I guess.
Definitely, very interesting point, yeah. Andrea, you have something to add?
Well, I totally agree. I think that factory of the future type of use cases and scenarios are very relevant in general, where you need a dedicated network in which you might have technology to implement technologies that for the services that we were talking about. And also another use case that I might add when I think of sensing, for example, is for assisting fragile people, for example. That is a scenario that is interesting. I know, colleagues that are working on neuroscience and others that with the new capability that technology is provided are really look forward to have the opportunity to, for example, see if people start to move differently, to know in advance if the brain damage is occurring at hospitals or in another situation, And of course, there are many technology that one can use. One can think of camera, but then in a certain situation, camera have some privacy issues, so you cannot
concerns.
do. Yeah, there is some concern. So wireless sensing, radio sensing, and localization are technologies that can help also in these scenarios. In addition to those that were mentioned in
I think this is a big challenge as well. So, for example, I mean, you cannot really sense everything, right? I mean, whatever you find around you, there are these societal sort of concerns, right, about sensing and environmental monitoring, let's say, or something.
Absolutely. And then you want to build a digital twin of the environment, but also the digital twin of the network.
Of the network
because
as well.
you want to control the network in a more efficient way. And so that's...
It's quite interesting to see. In vehicular communication, for example, you have, let's say automated cars. So it needs to sense the traffic lights or the, other cars, other vehicles and, some pedestrians or something. So it needs to monitor that, but keeping in mind that the data is secure enough. Or are there any sort of activities going, let's say, on this, any work, any research things that are going on, let's say, on the security and privacy aspects of these technologies?
I think security and privacy is a common subject we have in mind anyway. And I think the attention to this and the sensitivity of our private lives also to be sensitive against some breakage and giving away some private data, of course, has to be monitored. And I think it's really the key to share only what is requested or what is needed to take the right actions, right? And of course, there needs to be intelligence to decide upon that, and maybe machine learning based as well, right? To say, okay, in what cases do I what information needs to be shared, and make sure that, of course, it is secure and cannot be getting out of the system to be misused in some way. I mean, this is a general task we have to fulfill anyway.
I would agree. I think it's a common theme that's going to span kind of everything when you think about security going
And when
forward.
do you think, like, about the AI, let's say, what do you think, how it can leverage in such scenarios? Because security privacy is a concern with AI techniques and machine learning algorithms as well. So what do you think? Are there any activities going on to tackle these, or any sort of research-based or development-based work?
I'd say it's always part of the conversation to consider training data and test data sets and what approaches need to be taken to ensure that, as Mike just said, like only the relevant data is actually provided, and is it provided in a way that is secure, anonymized, in line with the right frameworks and security procedures. And I think that's a work in progress that will keep evolving.
So we're evolving.
It's definitely an important factor, and maybe a limiting factor for some aspects of what AI and MLs will be used for.
Like one of the use cases that I can think of is public safety. Andrea, you might be working on this. Is when you use the drones and, let's say, satellite-based connectivity, the direct access from your satellite to your smartphone, right? So in those scenarios, when you have, let's say, some sort of disaster happening, right? So you need to detect some object, you need to extract some information because the link, the access point is broken, right? You don't have the base station serving that region anymore because of the disaster that you have had. So in these cases, sensing and communication can play a big role. You want to sense, you want to communicate information, and so on, right? Or any other use cases you can think of? This is what I think of in terms of, using sensing and communications.
I mean, these disaster situations are, anyway, I guess, a very important use case, right? Even without the sensing, I guess, to enable the communication being established again is a tremendous important thing to be able to do. And I think it's important work. And then, of course, if you then know even more, that would help in setting up this communication right again, can only help, right? So this is a great addition into this. So there are two things that come greatly together, I would say, in that scenario. But I think the disaster scenario itself is a very important use case, just to enable communication again, which is a trigger for being able to do this.
And are there any other challenges there are into realizing all these sort of use cases? Can we think of some challenges? Like, for example, I can think of the channel modeling, let's say. Many, Andrea says. So for me, I can think of, let's say, the channel modeling, because you have been dealing with, conventional channel models when you're dealing with communication. But when you add the sensing capabilities, you have different sort of modeling of channel. So as you mentioned also at the beginning, so this is one of the big concerns. Then the data handling, because you have so much of data because of this combined information. Then maybe some interference problems, right? That the interoperation interference, or when you're dealing with multi-user sort of thing, multi-cells and so on, or cell-free sort of scenario, you have interference problems. So, Andrea, would you like to touch on some of these, or?
You mentioned quite a few. I think all of them are quite a relevant issue for sure. As long as we go on the way of machine learning based or AI based, techniques for either communication. I can think that the new type of decoder, as well as for sensing and localization we were talking about earlier. Of course, the training of the data is important. So you want to be able also to build systems that can self-train also quickly. And this is one of the issue. For example, when you build some demonstrator in your lab and then you move around, there is some need of new training campaign in some cases, and you cannot waste hours or to do that. So building some system which is robust, that is able to operate sufficiently well with knowing some target specification for the performance, even if it is trained in different condition or maybe even in standardized condition, right? That they are not tied to any specific environment. I think this is something that is important to work on.
Yeah. Clearly, from a machine learning perspective, of course, I mean, the new thing we are facing now is coming from TS to measurement. You have kind of reference conditions always, and you're seeking for them to make a checkpoint. This is fulfilled. Now you have a moving target kind of, so things change. So how we cover the possibilities that should be possible, of course, at the very end, but not too much, because we cannot do this obviously in all cases, right? Because there are just millions or too many of those. So reducing the adaptation kind of characteristic test task to the minimum, but then still allowing that or ensuring that it works at the very end. I think that is certainly a challenge people are working on right now, and that we will work on for a few more years, months, at least I would say. Yeah. So it's not a done deal yet, but we will see when we go along. And as Paul was describing, I guess we do as usual steps, right? We try to modify one thing first, maybe a few more then, and then by doing such in cooperation with partners, universities, industry partners, a lot of projects are running right now as we speak, right? So we try to solve that as an industry and or as a community, I should say, and then find hopefully the right methods to do.
Yeah, and those initial challenges from the test perspective, like you've described, have already been happening with what we're considering now in 5G Advanced, right? With some of these first introduced AI for error interface concepts. It's been interesting over the past year and a half in RAN 4 in the test group of 3GPP, considering how we ensure that what we test in the lab actually has meaning. When it comes to AI models, especially if there's a lifecycle management element and things could change in the field. What does that mean for, does the test in the lab actually have any value at that point? Things can just change afterwards.
Yeah, deploying it outside the lab is a completely different game.
So how do we manage that? Can we do any kind of testing live in the network? That's not a traditional approach that, we would do. We do conformance and then it's done. So it's definitely a very challenging topic. And
there may be some regulatory and compliance issues as well, when you're especially, dealing with different regions, different areas. So maybe in NTN case, for example, if you're trying to combine with ISAC, trying to provide the sort of services, then one satellite can cover different, many regions, many areas. So you need to know how to do this compliance issue, how to solve this, even with a dual function, let's say ISAC signal or something. But there are issues, no?
I think also regulations are in works, right? I mean, for machine learning, we have a lot of acts now maybe coming to place or being prepared with the world.
Yep.
And also this, I guess, is a starting point of something that needs to develop over time and hopefully something that really works out at the end. It's clearly something new.
And here, so let's say, we discussed several challenges, and of course we are aware of several of these. And what do you think the future of let's say 6G looks like? So we know that we have these enhanced capabilities added into it, but do you think these are sustainable? So even beyond 6G, right? So we say that, okay, in 6G we'll work on these, items and work item study items. They are included in, 3GPP releases, then pre-standards activities, then a lot of academic work has been also going on around these, right? But do you think, are these sustainable over a long period of time? Or these are something that are just 6G based and we will come up with something new in, let's say, beyond 6G, 7G or something?
I think it's interesting when you look at a lot of the, let's say, foundational technologies from 4G to 5G and now moving towards 6G. There's definitely an evolutionary aspect to a lot of those. Take MIMO for an example. Massive MIMO was the kind of flagship radio technology in the 5G era. It's been very successful in demonstrating performance that was in line with the gains expected from academic study, and I think that's something which is only going to continue to evolve and take over with FR3 maybe, and more complex in some ways, but then also perhaps with AI and other techniques, ways we can manage that complexity. But that's more of a foundational thing for the whole radio access, I would say. Whereas perhaps you look at some of the other technologies like ISAC, NTN, I mean, that's also ongoing, but I would say NTN is something which is perhaps coming along in the 5G timeframe, but I would envision reaching more maturity.
Actually, you also see some of these technologies are not that new. I mean, we have been discussing many years ago, with NTN per se. I mean, it's an old technology, but
it's more the integration and harmonization with the terrestrial part, which I think is the new bit, and that's been what's started to get tackled during 5G.
You're not replacing the infrastructure, but you are complementing it with additions.
And you're seeing it's interesting seeing the presence of the satellite operators and vendors in 3GPP and trying to kind of work in that world and start to hash out some of these challenges. So I think that in line with that, like back to your original question, I would say many of those I could see carrying on 7G, 8G, whatever. I think there's a trajectory where there'll be a continuing like maturity almost of evolving and improving and refining. Then I think maybe there are some more unknowns as to how the use cases will play out. I think ISAC is a very exciting one. We need to look at the different types of ways that can be adopted with things like bistatic, monostatic, these kind of different approaches, how they suit different scenarios, how they work with different access technologies, and also the deployment sizes, right? When you're considering certain use cases, are you expecting there to be coverage at a macro level to provide that capability? Or is it something which actually that's not necessary? We can use small cells with a higher frequency band to do that kind of purpose, and it'll be deployed more as required type approach. And then factoring that in when we're talking about the types of applications, like traffic scenarios and sensing with people in care.
Yeah, this is important. Also, you see that these technologies like ISAC, right? So we have these 32 industry use cases in the 3GPP release 19, right? Related to robotics, smart healthcare, and many other sort of applications. But many of these may make the list, when finally 6G is completely deployed, the infrastructure, 6G-based services there are. Many of these may not be there, right? Do you think that would be the case, or we will have more new use cases coming and more new sort of opportunities coming in next few years as we are evolving, right? Because we are playing with something very beginning sort of thing, like with communication assisted sensing or sensing assisted communication. Or do you think that we have like a complete joint design where we play around with the tunability of these, and how will it go? Any thoughts?
I think this is really also depending, of course, always on market needs and opportunities, right? So first things come first, and then it's going to start to evolve. And maybe it's also sometimes depending on side effects, like is there a new device type available that can even better support it? Now I'm thinking, do we move away from our smartphones to something really like, okay, these goggles immersive, are more not very usable at the moment, let's say, but let's assume in a few years' time from now that really my form factor glasses are capable of injecting some additional information into my view field. This will, of course, add new opportunities, fuel new use cases. I think we are laying the foundations now for these possibilities to evolve then over time. And this will then, of course, always also depending on market needs and also business cases that are successful, that will fuel that industry and move on. And that then can go on for many generations. Like we use smartphones now for 3G, 4G, 5G times, right? Maybe the next generation of devices will again last for multiple years
for a long period of time.
And of course now we are mainly talking about wireless aspects, so radio access network, but those use cases will also require continuous evolution in the core network, because there will be many of the application and use cases we talk about require some really control end-to-end latency in most of the cases. And so which type of processing you move to the edge, which type of processing you cannot move to the edge, and it is going to be cloud native or cloud based. So
exactly.
Then these aspects of latency, in addition to all the performances we were mentioning earlier, I think require a continued evolution of the core network, in addition to of the wireless technologies.
Yeah,
and the
perhaps you also
processing.
need to think about more performance metrics. I mean, new ones on board. We have these KPIs and everything, but new performance metrics you need to come up with. I mean, to really improve the performance and have a balance of these multifunctionality.
Absolutely. The XR is a good example for that, right? I mean, today we use data rate requirements, or you have a certain audio quality, but in the scenario where you move your heads, and then of course the movement comes on top, then it's latency plus data rate. It's a quality of experience you need to rate. So we need a combined figure of measuring that and assessing that performance in controlled environments, again, for some conformance. And then, of course, how good it works in all scenarios in the field is something to come on top, right? And how far we need to emulate that again for some kind of minimum performance limits to be tested.
Exactly. That's great to know. So are there any other activities you would like to mention, or any research work that you have been working on in your companies, in your groups that have been going on? Are there any things that you want to touch on from your groups that you've been working on? Andrea, maybe you can start.
Well, okay, maybe from the research perspective, you mentioned at the beginning many topics. I think, talking about wireless technologies, I think the use of reflecting intelligent surfaces is something that for some use cases is going to be, give a new push in the performance improvement, not only for communication, but also for localization in all those scenarios where you need to control and shape your electromagnetic environment so that you can go through, no line of sight conditions or complex wireless situations. Also, for example, in my group, we are start looking into quantum information science and how to exploit quantum mechanical properties for improved communication and sensing. And for us as engineers, is difficult topic, but we are very enthusiastic, and we are learning some basic in quantum mechanics, and slowly we are getting into how to design quantum state for improved sensing, for improved communication. And this is something that I don't expect is going to happen on the time frame we were talking about these use cases, but maybe 7G, 8G.
7G, 8G, No, my group as well. I mean, in our group, we had done one paper very recently on combining quantum with DRL, with deep reinforcement learning, and to really enhance sort of accuracy level and also come up with sort of cost-effective sort of approach in sort of a military surveillance sort of scenario where you have the meta surfaces combined with the ISAC signaling, and you are using it, for the UAVs and so on. So everything combined together. So we did like a paper in JSAC very recently. So it's a very nice point that you touched. This looks like the future of technology, that you combine multiple technologies together, not just standalone sort of aspects. Paul, would you like to add something?
Yeah, so I guess a couple of others as part of our 6G testbed that we've been looking at, rate splitting multiple access. So considering how the blend between a technology like NOMA, non-orthogonal multiple access, and multi-user MIMO could be achieved with that kind of approach. I think it's an interesting concept, and again, it's another one that we've looked at and thought about in terms of what it would mean for how the network would operate with grouping users, and how that would maybe change certain requirements when it comes to testing. The other key one, and it kind of links to the ISAC stuff again as well, is ray tracing. So we've been working a lot on our in-house ray tracing tools to do more real-time ray tracing with AI assistance, and we're considering that in a general sense, but also looking at the different types of scenarios in a 3D way, so NTN down to like UAVs and all the way down to terrestrial. So the different dimensions of access that could be needed in terms of channel models and ray tracing, and how it ties into ISAC from a point of view of considering the need for ray tracing with these channel models and how that will change. So to name one, I mean, many people are looking at it, but Next G Alliance have done a lot of work in the US from a pre-standards perspective, investigating this in tandem with the
There have been several white papers as well around these ideas.
Some great white papers. It's been in line with kind of what's been evolving in 3GPP and considering the stochastic and ray tracing requirements for having the right type of channel model, as was mentioned, introducing reference objects and these kind of things, and evaluating that quite thoroughly. So we've been looking at that in line with our ray tracing development and hoping to be able to contribute more in that space going forward.
Interesting. Mike?
Well, of course, not much left maybe from all the things that we discussed already. Just one maybe, although these higher frequency stuff is maybe not the next week thing to go for, so we all know maybe this is also a little bit longer down the road. But we're also looking into ways of creating these higher frequencies, because we are out of an industry that is used to upconvert things from the lower frequencies. But there are ways of using photonics, laser communication, mixing signals, creating high stable and high tunable or widely tunable signals in that target frequency range. And that is also a very interesting field, I guess, to do that we are working on in various projects, and maybe something for a longer horizon of application.
Great. I think we had a very nice discussion. Thank you so much for sparing time and sharing your thoughts on these interesting sort of facts and technologies and so on. I definitely learned a lot, what has been going on and what the future looks like and so on. So thank you so much for coming to our podcast, and hopefully we can meet on a different podcast talking about some different things on a different day. So hopefully we do that at some point. But thank you so much for coming, and we will meet later. Yeah.
Thank you.